I know. My water. I've been looking for it the whole time. Yeah. You can go ahead, sir. There's gonna be 18 bucks. Okay, we are get started. If you wanna use the mic like closer. Or you can move to that.
I think for the first, I'll just use it. Hello, everyone. We'll get started. Here, my co-speaker, Dianhuan, and myself. So I run the machine learning team at Zscaler, and then Dianhuan is the brain for our team. So I'll just spend just a few seconds to discuss what Zscaler is, just in case. Zscaler is literally the world's largest enterprise zero trust cloud. When you think about the enterprise users, Fortune 500, 40% of the Fortune 500 users, they are trafficking through Zscaler cloud. Every day, 250 billion transactions going through Zscaler cloud. If you think about it, what does that mean, right? How many Google searches a day? That's roughly 8.5 billion searches a day. And a Google search to us is one transaction. So if you think about the scale, Google has 8.5 searches a day, and then we have more than 250 billion transactions a day. So the level of the scale is probably beyond your imagination if you didn't study the Zscaler. So with that, I wanted to talk a little bit about why we are discussing this, right? So I actually have been in the security industry on and off for almost 25 years. I actually was one of the original person who wrote IPsec code for FreeBSD 2.0 back more than 25 years ago. And I joined a company called NFR. I don't know how many of you ever heard about NFR, but I couldn't even find a clear image online this morning. But that was back in the days, one of the pioneers of intrusion detection in the 90s. And a few years ago, I started a company doing AI machine learning. It's called TrustPath. It was acquired by Zscaler. That's why I'm part of the Zscaler team now. Now, why AI machine learning? Because there is something that I learned many, many years ago. I felt like, wow, that's a huge pain point. Jackie, over there, I listened to your Zoom talk about for 10 minutes. My 3 takeaways from your talk. One is we are screwed because the hackers are winning. Second, we are finally together. And the third, we need more women. So that's why I have a co-speaker. But I'm going to talk about the first 2 things a little bit. We are screwed. So back in 1998, I was reading this paper. I don't know how many of you read it. Insertion, evasion, and denial of service, eluding network intrusion detection. This was early 1998. I read this paper. I truly, truly believe we were screwed because the way I read the paper, I don't know there's a solution for that. We can do intrusion detection all day long, but bad guys can just get ahead of us. Whatever the security solution, you are going to be half a step, if not 10 steps behind for all practical purposes. As a computer science guy, no matter how you look at it, it's just, you cannot argue against that paper. So that's why, part of the reason I actually sort of left the security industry a little bit. I went on to do VMware. I founded a VMware's networking team, and I went on to do virtual networking later on. But that was part of the reason I was a little bit disappointed because, we really didn't have a way to deal with security because, no matter what we do, how fast we can come up with signatures, we are always half a step behind the bad guys. And the problem is even worse in the last 20 years. If you think about the SolarWinds, right? So when I thought about it, again, using first principle, how to solve that problem? Well, there are billions and billions signals and then data points we could have potentially gathered, process it, and then make sense out of it, and then got ahead of the bad guys. But it's actually pretty difficult. I think Jackie made the same point, right? where's the data? Is the data clean? Do you have the power to even process the data? It's just a lot of work, right? When you think about it. That is the motivation for our talk. We actually wanted to talk about how Zscaler, my team, right, think about solving this problem. This is a part of the reason why I founded a trust path a few years ago. I was thinking, wow, finally, there's some technology. It's not a silver bullet, but it is a technology that has the potential to deal with this, paper that was published back in 1998. And I really argue the entire networking industry, security industry, never had a solution for that paper, never, ever. And then, but AI machine learning give you a hope that we can complement, not replace, but complement the existing conventional technology to solve that problem. So when you look at it, right, security industry is a little bit reactive. We wanted to be more proactive. We have very limited security operation guys. We want 10x. Ideally, if you ask any CISOs, they want 10x, 100x people to deal with it, right? That's in practice, but we don't have that. So that's why we need AI machine learning. Now, we have been talking about using AI machine learning for security for many years, almost 10 years. I mean, I'm talking about even in the mainstream corporates, like I say, right? I'm not even talking about papers. We've been talking about malware detection, URL categorization. This is almost, I wouldn't say it's a solved problem, but this is a well understood problem. We are, as a company, Zscaler, we have put that into production for the last few years too. But as a zero trust leader in the industry, we are kind of getting, solving newer categories of the problem. There are really two categories of the problem we are solving. One is, dealing with the threats, ever more evasive threats, right? Threats just, wanted to easily get ahead of us, right? That's one. The second thing is really the policy. That's actually less understood and less dealt with in the last 20 years. If you think about zero trust, right? It's about, which user can connect to which applications. It's not a problem until you deal with 10,000, 100,000 users and 10,000, 100,000 applications. How can you do that in an accurate way, personal way, the contextual, and the dynamic way? How to do that? It's actually, you need some potential AI. This is not the focus of this talk. Our talk is more about evasive threats. Dianhuan is going to talk more about it. We actually, once we got into Zscaler Trust Path team, Dianhuan is our first hire into the company. She came from, the Amazon kind of the Alexa kind of background, right? Knowing a lot about the data science. And as a company, we know a lot of the security. Zscaler, you're right. We just celebrated 15 years of the anniversary, and we have a lot of data. I showed you in the first slide, 250 billion transactions. That's like almost 30x of the Google searches a day. Think about it, right? And how do we deal with that? But one thing I want to say is, in order to deal with that, it's not just knowing AI machine learning model. Dianhuan actually went a very long way in the last almost 4 years, 3.5 years, to actually get closer to the security, merging, right, the two disciplines, AI and the machine learning and the data science. So with that background, I wanted her to discuss more of the, more technology and also some some case studies.
Thanks, Howie. So here, as you see on this graph, where Zscaler AI machine learning is built on top of 3 pillars: model, domain knowledge, and the data. And here I want to elaborate a little bit more about the data part. So Zscaler actually have 240 billion transactions per day. What does that mean? Google search transaction per day. Anyone the current number for the Google search TPS per day? Oh, okay. So with that, how you talk about that, Zscaler has enormous amount of data, and most of the traffic there are actually benign. Only tiny bit is malicious, and finding those malicious one is like finding the needle in a haystack. And what makes it even worse is evasive attacks actor usually disguise their traffic as normal as possible. So the key for solving this solution is how to find a way to separate the signal from the noise. So now I'm going to introduce you our special recipe to do so. So the most critical ingredient for this is a multi-dimensional data. So the first dimension is about the deep packet inspection. So that means we do the SSL decryption for each of our transactions so that we can get the information like the user agent. And the second dimension is about putting the transaction in the context of time, see what happened before and what happened afterwards. So this allows you to really see what was going on. Imagine if each transaction is like a leaf, and this putting in the context allow you to see the tree. Now the third dimension about the cloud effect is really help you to see the whole forest. As Howie mentioned, Zscaler is a SaaS vendor. That means we have the data about all the companies on the cloud. By the way, the PI data has been removed when it comes to the model for analysis. Now think about the threat actor. They usually attack multiple companies. Now with Zscaler's cloud effect data, you are able to see the whole landscape about how the threat actors evolve in time and then how it change from companies to companies. It's interesting to see that a lot of them share some common characteristics, but at the same time, there's some evolvement going on there. So now we got this precious multidimensional data. We still need a powerful modeling techniques in order to get the insight out of this multidimensional data. So our approach is innovation over the existing ML approach. It's a hypergraph-based machine learning approach. Now I'm going to use a concrete example to show you what this multidimensional data mean and what our approach is special about. So this is a real attack that delivers ransomware at the end. It does happen to a handful of Zscaler customers, but the good thing is we were able to detect it and block it before ransomware was delivered. So there were three invasive tactics in this attack. First, it was using the drive-by download to trick the user to download a zip file, which looks like a normal Chrome update. And then if you click, and then in that zip file, it actually contains a malware, which contains both the blister loader and the Cobalt Strike beacon. When the blister loader gets executed, the Cobalt Strike command control started. You might be thinking, in this attack, if we were able to detect this blister loader, then we will stop the attack halfway, right? But unfortunately, this blister loader is very hard to detect. One is that it was modified from a legitimate DLL, and also using the radical signing so that it can persist in the system. It was able to bypass the EDR vendors, actually. So this is from the actual log where for the customer being impacted, the one highlighted in red was this particular malware when it arrived in the endpoint. And then you see in the log, there's actually some transaction to the EDR vendor. So that shows that this EDR vendor was active when they see the file, but still it didn't manage to stop the file. And because you see beacon, it happened afterwards. And on VirusTotal, the detection was very low at the beginning. And you see a jump. That was because vendor published a blog, and that's why the other vendor catch up. But in fact, Zscaler was able to detect 1 month earlier than anyone else before. And here I also want to highlight it, even though now all the VT, VirusTotal know about this file being malicious, but still no one knows about where this file download from. The IP where the Galo file download from still looks like benign, and there's no information about how it's associated with this attack. Okay, now this is the exciting part, how we detect it. As I mentioned earlier, we are able to put the transaction in a context. So when you look this transaction alone is hard. At the most, you see the user agent is normal, and there's a DLL file. But when you look what happened afterwards, 10 minutes afterwards, you see there's a deepening to a particular domain. Now the model has a hypothesis, putting connections between these two domains. You might notice we put a dashed line instead of a solid line. It's because it could be still coincident at this point. Just like I go to yahoo.com and then I go to CNN.com, doesn't mean that they are definitely correlated, although they might be a transit connection. And that's where you might remember the third dimension about the cloud effect data. When you see that this is happening across two different companies from two different sectors, then the chance of being coincidence is lower, and then it's more likely to be correlation. So now the model have higher confidence. There's a correlation between these two domains. And what we see was just one of the many connections we are building by the model. And then you see in this graph, some of them was forming the clusters there. And we zoom into one of the clusters, is one of what which we're looking at earlier. This one was what we're looking at, but there's in fact more than the more connections to this. They are all shared by the same users who being attacked by the same attack. And if you look closer, you see that the some of them share same ASN information. So the graph here we see is no longer on the flat ground level. You actually see the higher order logic there in terms of the correlation. You can see how it correlates from different dimensions. That's why it's a hypergraph. So this is the detection we are able to detect use our special recipe. And this is a quick list of IOCs. This might look familiar to you. That is what you typically get from the threat intel. It gives you a flag list. But earlier you see what we are able to do by our approach, not just give you catch some of detection early, but also we help on the model explanation, how we digest what this threat could be about. As we see earlier, it's not a flat list. We give you a visualization to see how they are connected. And also that if you double click on one of these domains, we give you an explanation card for each individual host. So some of the subset of our features and the feature value and the feature importance, say which one is playing the largest role in detecting the particular host as likely suspicious. We also have the data about the preference. So many of you have been working on the SOC team, you might remember look at the data in your own environment, right? You see when was this host was around. But now with the Zscaler's cloud effect data, you actually see it across the multiple companies, see what earliest point it actually arrived, and then how it was evolving. So you get a better picture about whether it's likely to be something new or old, not just from your own environment, but across a different environment. Someone might thinking this graph looks familiar. ViceTotal does give us some relational graph, right? True, ViceTotal is very helpful. But this particular case, this particular graph, ViceTotal tells us is correlated to two domains. And one domain is this access.com, still looks like benign. The other one is Akamai's.net, again, benign one. So meaning that at this point, again, ViceTotal know about this file being malicious, it doesn't know how it's related to other C2 domains or where it downloaded from. ViceTotal is very useful, but as you can see in this particular case, it was not comprehensive enough for some of the invasive attacks. And what we're doing here is able to complement ViceTotal and give you more early detection and more importantly, the insight into what's really happening. So quick recap, the reason we're able to do so is because we are able to put the transaction in the context. And also we have a cloud effect. This is something we can do manually, right? Like Howie said, it's all about the scale. I want to call it out. In the case of scale, a lot of us might be thinking, oh, it's just parallelization, right? If I have enough machine to parallelize it, it might solve the problem. I want to call it out the challenge there is more than that. Because think about this. So each transaction going through Zscaler's process, right? decide whether it's malicious or not. If it's one transaction, it's easy. Just like people going through the airport scanning, security scanning, each people passing by check only this person. That's easy. But if we ask about the context, meaning that each person needs to bring a log about what they did before and afterwards as additional information for us to check. Think about the memory required for that. Originally only have one transaction, but if you ask this person to bring past 1 week, even 1 month data, that's a lot, right? So how do we handle this memory and then and be able to digest those information? Even though they are able to bring you, are you going to do this 30 days fast enough? So that's where the challenge in terms of our early approach give you the hypergraph that's based on very efficient computation, not just on memory, but also in computational complexity. And most importantly, give you the insight that you need. So this multi-dimensional data is very powerful. I give you 2 examples, but I don't mean that that's the signal. There are no single killer features. It's all about the connection among them. So that's why we need AI ML to come in to learn how to combine these different signals. In case somebody wondering what models we're using, it's not just one model. There are actually more than 5 models, even more models underneath. So some of them are deep learning model, for example, to detect whether it's a DGA or not. And some of them are unsupervised learning model to detect anomalies. And some of the layers at the end was in the supervised learning model to learn from the past training data, how to correlate the data together, signal together to make a final verdict. So it's really a suite of the different models working together to solve this problem. And finally, for my session, I wanted to close with about emphasize the comprehensiveness of our model. As we mentioned, insight that we generated from our model is the most important one, right? So we're not just happy with, oh, we detect this early, that's all. We also wanted to make it possible for you to digest. This is why it's important. I want to share with you, this is an article on Nature published actually 16 years ago. Scientists already called it out that with the success of the big data, it's actually coming with the dangers of the trade-off in decrease in comprehensibility. With that, some of you working with AI machine learning, you might have this experience about the black box model from ML, where it gives you prediction about why. So that's definitely something we are well aware in terms of one is Howie, but also help the model to improve further. Because if we don't know why model made a mistake, you'll be almost gambling to try which approach to do to improve the model to the next, to take it to the next stage. So that's where the comprehensiveness is critical for the customers who consume this intelligence, and also for developers who build a model to really understand why and then take it to the next stage. And this is actually an article written by my PhD advisor. And this is also research I've been doing for my PhD. Make the model interpretable, just like how human beings would do. And I'm very happy to see that we are able to make this really happening in the industry, not just a comment and warning that this could be a problem. Thank you.
So at the beginning, I mentioned that if you think about this security problem, a lot of that has to do with leveraging the data, leveraging the AI. And Dianhuan, hopefully we give you this story that the scale is what we wanted to overcome. I remember when I came to Zscaler after the acquisition, our human resource head came to me and I said, "Hey, Howie, can you actually explain to me why we need AI and machine learning? Because we have been doing security for the last 10 plus years." And it took me a long time to even figure out how to explain to someone who didn't know the technology. And I thought about it for months. And then later on, I had this aha moment. And I thought, well, there is only one word I should have explained to you, which is the scale, right? The scale of the data, right? The scale of the, all sorts of the behavior, how do you correlate them together, the cloud effect. The scale is really the challenge. That's why we need to combine the conventional technology and then the rule-based or domain knowledge reverse engineering together with the AI machine learning data. Hopefully, we give you that story, give you concrete examples. And as I mentioned earlier, like cloud native security is about invasive threat detection. It's also about granular policy. And in the future, we see that it's actually more than that. Hopefully, we will get to the world that AI and then data native security, meaning that the data is going to drive the policy, data is going to drive the detection. We are not there. We're still very far. I mean, today we are still probably just like helping or assisting the domain experts, but we hopefully play a bigger and bigger role. And at some point, right, the self-healing, but that's going to be the nirvana. I think the bad guys are going to advance and they are going to take advantage of AI and machine learning as well. So it's going to be an interesting battle. But I do agree with Jackie in her keynote, in her opening speech, in that the only way for us to tackle this problem and combat the bad guys is here together. By here together, leveraging the data together, by hopefully we give you shared intelligence. And this is one of those things that this is the end of our presentation. However, if any of you have any feedback, we would love to hear from you. There's a survey form. You can just fill it out, only 3 questions. And the other thing is, if you feel like, hey, this is kind of intelligence, this is kind of the approach that's very much interesting to you, we would love to follow up with you offline in terms of the advance the technology and or maybe sharing the data, figuring out some ways to sharing the data with the community, and then so that combat the bad guys together. So that's our talk. Do you have anyone have any quick questions? But we do have the QR code and we have the survey form, and feel free to reach out to us. You can take a picture of our contact information too. Thank you.